We are going to discussing molecular orbital theory. It is molecular orbital theory is nothing but it is based on the combination of atomic orbital. So how molecular orbital theory work, how orbitals can combine to form different sigma orbitals, what are the bonding levels and what are the anti-bonding levels. So all these things which we are going to discuss in this lecture. So see, molecular orbital theory, yesterday we have seen that what happens in the case of MOT, where you can have a, if somebody may trying to join the lectures, so I must allow them. So see, it is according to this theory, you can have a, what happens, according to this theory, you can have a molecular orbital, which will play an important role. So what happens? See, orbital involved in the bondings are of two types. Some orbital may form sigma bond and some orbital may going to form pi bond. So you can have a two types of the orbitals that can involve in the bonding. So among them, proper symmetry should be taken into consideration. Okay, symmetry, when symmetry is going to match, at that time you can have a particular types of the bonding. So you can match with appropriate symmetry. The number of molecular orbital that having same symmetry with the ligand group orbitals, they can form this molecular orbital. Metal orbital having same symmetry with ligand orbital. So what happens? You can have a, the in covalent bond is formed by linear combination of metal atomic orbital and ligand group orbital. You remember, metal atomic orbital when combined with ligand group orbital, not a individual free ligand, but ligand group orbital. So you may got metal that is covalent bond. So symmetry of ligand group orbital must be matched with the symmetry of metal atomic orbital. Then and then positive overlapping is take place, and you will get particular covalent bond. So here this bond is formed along the, so here see ligand group orbital with metal orbital along the axis, along the bond axis. So that is result into formation of particular bond. Especially see here you can have a for sigma bond. How sigma bond is formed? So see this is a octahedral geometry with z axis is along the ligand axis and x and y axis are perpendicular to ligand axis. You may assume that see this is a ligand axis. So your z axis is over here and x and y is perpendicular to ligand axis. So in this case what happens? See x and y is perpendicular to, so here this along the axis which is responsible for forming sigma bond. Along the axis which is responsible for forming sigma bond. So here these are the, see z axis is responsible to form, you can have a sigma bond because z is along the axis. So in octahedral complex, ligands are approaching the metals cation on x, y and z axis, and therefore you can have a ligand group orbitals will overlap with metal orbitals and it form the sigma bond. So you will get the sigma bond. See there are three different cases. One is formation of sigma bond and second one is formation of pi bond. Pi bond is possible by two different ways, by ligand to metal electron donation and second one is from metal to ligand electron donation. So there are two different ways are there for pi bonding. So this is the case for sigma bond. Now, which orbitals are responsible for sigma bonds? So of course, 1s orbital, or you can say A1G, is responsible to form sigma bond. In case of p orbital, yes. In case of p orbital, which one is that? T1U. Okay, Px, Py, and Pz is nothing but T1U. It is responsible for forming sigma bond. And dxy, dyz, and dxz. Among these three, here what happens? You can have a sigma bond is formed by and another set is EG set. So two different set is there. So which set is responsible for sigma bond?
EG.
EG set, yes. So here EG set is responsible for forming sigma bond. Here it is T1U and here it is A1G. So what happens? See, these are the three can form the sigma bond. So T2G cannot involve in the sigma bond. Remember, T2G cannot form sigma bond, and that's why see whenever you go for its diagram, so T2G orbital is lies between the axis and therefore it cannot form sigma bond because sigma bond is form is along the axis, and that's why T2G is not along the axis, along the ligand axis. So T2G cannot form the sigma bond, you can say. So what happens? So in this situation, see if you go for its diagram, so for that, see you can have a symmetry adapted linear combination of ligand orbital that is called, you can say, you can also say SALC, that is called symmetry adapted linear combination of atomic ligand orbital. So this is also called SALC. Okay, it is called linear combination of symmetry adapted linear combination, that is called SALC. So according to this way, you can have a, see, ligands individually don't match with symmetry. So you require ligand group. Okay, all ligands don't match a symmetry of metal atoms, but they adjust themselves by individually interacting with metal. But ligand group orbital are responsible for matching. So all six ligands interact equally with the metal center. So in this situation, see what happens. Look at here. You can have see two types of possible combination when you look at the possible bond formation. So there are two types of the possible combinations. Which are these two types of the possible combinations are there? So you may have a one possible combination is, you can say, that is bonding, and another one is anti-bonding. So yes, so you are going to make two types of the combinations. One is with bonding formation and second one which is with anti-bonding formation. So there are two types of overlapping is there, and overlapping is of course take place between metal orbital, metal component, and you can have a you can say ligand orbital. These two are responsible for overlapping. So suppose if you go for psi molecular orbital, that is, so this is possible by, you can say this is for metal orbital, psi tau is a metal plus sigma, you can say sigma ei phi, that is called ligand group. So this is a ligand group orbital sigma set, and this is called orbitals of central metal atom. So these two can combine to give bonding, and for anti-bonding, the sign become negative. Yes, so you can have a, for anti-bonding, it's a negative sign. Now, how orbital gets transformed, different orbitals. So first we go for different orbitals of ligands. So ligands, and you can have a see metal orbital. So orbitals of metal is suppose yes. Orbital of metal is, you can say, Metal orbital is, you can have a s orbital, where ligand group orbital is, so symmetry label is, you can say A1G. We label it as A1G. This is a symmetry label. So corresponding to that, the ligand orbitals are 1 by √6 under root psi 1 plus psi 2 plus psi 3 psi 4 plus psi 5 plus psi 6. Or you may write down sigma 1 plus sigma 2 plus sigma 3, whatever is convenient to you. These are the metal orbital, and this you can compare the symmetry. Now for Px, Py and Pz. For Px, Py and Pz orbital, you can have a T2G set. It is transformed to Px, Py and Pz into, you can say, T2G. So how they get overlap? How ligand orbital can corresponding to this Px, Py and Pz? So see, this is by this 1 by 2, you can have a 1 upon √2 under root 1 upon under √2 sigma. It may be 1 upon under √2 sigma 1 minus sigma 2, you can say, and 1 upon under √2 sigma 3 minus 4, and 1 upon under √2 sigma 5 minus 6. So you can have a, see, that is nothing but Px, Py and Pz. So here this is just a Pz orbital is a 1 upon √2 psi 5 minus psi 6. Px, that is 1 upon √2 psi 1 minus psi 2, and Py is 1 upon √2 psi 3 minus psi 4. So this is for transformation of p orbitals. So you know very well how that p orbital gets transformed. So p orbital is transformed into a different set of orbitals. So Px, Py and Pz orbital possesses transformation properties. That is, you can transform into a set of orbital that is called T2G set. So see, this is the case for sigma bonding.
Sir,
Here to, yes.
how can it be transformed? I did not understand.
ये कैसे वेव फंक्शंस लिखते हैं वो?
How can it be transformed? Px, Py, Pz.
शुरू में इनिशियली आपको यहाँ पे जब स्टार्टिंग किया था तब वो मूलिकन टर्म्स लिखे थे ना, दो ऑर्बिटल्स के लिए जी है, तीन ऑर्बिटल के लिए T2G है, ऐसे मूलिकन टर्म्स सारे लिखे थे ना.
Yes, sir.
वही उस हिसाब से ये ट्रांसफॉर्म होता है. एस ऑर्बिटल है तो एक ही टर्म आएगी मूलिकन, ये मूलिकन टर्म है. यहाँ पे भी लिखा है, देखो, P orbital is transformed into T1U. Of course, it is not a T2G, but it is into T1U. Sorry, it is transformed to T1U. Okay, so this is T1U and T2G उसमें आएगा D orbital में. और ये जो डेरिवेशन है ना, इट्स मैथमेटिकल डेरिवेशन, जो आप सिक्युलर डिटर्मिनेंट लिख के जो डिराइव करते हो, इसी तरह सिमेट्री से भी डिराइव कर सकते हो, बट दैट इज नॉट अ पार्ट ऑफ आवर syllabus, and that's why we are not taking that one. Otherwise that we can also understand. Quantum में है already derivation, तो यहाँ directly we accept it. अभी चलो d orbital है मेटल की, ये सारी मेटल की ऑर्बिटल है. ओके, 4s ऑर्बिटल है, देन 4p है. नाउ d orbital, हाउ d orbital gets transformed? So see, d orbital में जो dx square minus y square and dz square है, so they are nothing but which set? dx square minus y square and dz square, they are called EG set. Okay, So dx square minus y square is transformed as 1 by 2 sigma 1 plus sigma 2 minus sigma 3 minus sigma 4. आप ऐसे भी लिख सकते हो 1 by 2 sigma 1 minus plus sigma 2 minus sigma 3 minus sigma 4 ऐसे. And जो आपकी dz square है, it is you are getting wave functions for z square is 2 sigma 5 or psi 5 plus 2 psi 6 minus sigma 1 sigma 2 minus sigma 3 minus sigma 4 or psi 5 1 upon root 12 करके. So this is the corresponding C combination. Now what is left? कौन सी ऑर्बिटल अभी बाकी है?
T2G.
नहीं, ये सारी सिग्मा बॉन्ड है, इसलिए मैं यहाँ पे सिग्मा बॉन्ड लिखने के लिए आपको बोल रहा हूँ. यू कैन राइट डाउन हियर सिग्मा बॉन्ड ऑल्सो. अभी T2G बाकी है, but see T2G cannot form sigma bond. Okay, T2G cannot form sigma bond. T2G remains non-bonding in sigma bond, but of course T2G form pi bond. So how you are getting say pi bond by T2G? So T2G can be transformed into pi bond in this way. See, this is a T2G. That is dx y, dyz, and dxz. So you can have a C pi bonding corresponding to these two, 3 pi bonding 1 by 2. It is first one is pi 1 plus pi 2 plus pi 3 plus pi 4. Second one is 1 by 2 pi 1 plus pi 2 plus pi 5 plus pi 6. अभी एक और लेवल बाकी है, that is 1 by 2. What is it? Pi 3 plus pi 4 plus pi 5 plus pi 6. दो का combination आप लेके तो ऐसे आ जाएगा. So these are the pi component. T2G cannot form sigma bond. And see value of this alpha and beta coefficient you may got. See here, this is the two-way. This is a bonding molecular orbital. This is anti-bonding, and alpha and beta is a coefficient. And here see, this is a ligand group orbital psi L, and psi M is a metal group orbital. So they are combined in a two different way. Okay, alpha and beta is the coefficient. So you may got either bonding or it may be anti-bonding. See, this is a metal orbital. Corresponding to it, this is a ligand group orbital. This is ligand group. So now, see, you can have a alpha beta value. You can find out using mathematical calculation, that is using occult theory, or you may have an application of quantum chemistry. So, but see, alpha square is plus beta square is equal to 1. So if alpha equal to beta, then what happens? Alpha equal to beta, then you can put here alpha, beta is replaced by alpha. So 2 alpha square is equal to 1. So alpha is equal to 1 upon root 2. So therefore, see, covalent character, that is both metal and ligands are involved in the bonding, that is in a sharing, is if alpha equal to 0, then it is purely ionic. Okay, alpha value gives covalent character. If alpha value is 0, it is ionic. But if alpha value is 2, 1 upon root 2, then it is truly covalent. And if it is in between 0 and 1 upon root 2, then it is partially ionic, partially covalent. So in this way, see, from alpha and beta, you can find the nature of the complex, whether it is ionic or it is covalent. Okay, alpha value is 0, then what is its nature?
Ionic.
It is purely ionic. If alpha value is 1 upon root 2, it is purely covalent. Okay, and if it is in between, then you can have a both the character, that is sharing. So now this is picture is clear. Only T2G form pi bond where other orbital form the sigma bond. So T2G can't form sigma bond. Is it okay?
Yes, sir.
Okay, now see, this is the diagram for sigma bonding. If ligand which having sigma bonding, and you know that see 3D is splitted into how many level?
Two level.
3D is splitted into two levels, that is called EG and T2G.
सर अल्फा स्क्वायर प्लस बीटा स्क्वायर इक्वल टू 1, ये क्वांटम से डिराइव्ड है जो हमने हेल्प लिया है.
ये वो तो कोएफिशिएंट फाइंड आउट करने के लिए जो है ना, इट इज ए जनरल इक्वेशंस है, अल्फा स्क्वायर सम ऑफ दिस स्क्वायर ऑफ कोएफिशिएंट इक्वल टू 1, और नॉर्मलाइज कंडीशंस होती है ना, उसका यूज किया है. सी व्हेन दिस टू आर नॉर्मलाइज, psi a and psi b are normalized, at that time
Yes, sir.
alpha and beta are the coefficient, its square value will become 1. Alpha square plus
Yes,
beta
sir.
square is 1, and that's why see we have taken 1. And alpha represents the ionic, it is represent covalent character. So alpha value is 0, so it is ionic, otherwise it is having covalent. So we are just using it for application purpose, not on in details how to getting it now. It is another chapter. You may have some wave functions for organic molecule like 1,3-butadiene allylic system, psi1, psi2, psi3, जितने atoms है उतने wave functions like आप coefficient determine करते हो. The same way you can have this one, but here we are not using that quantum application and all these things. Now see, this is the diagrams. Now you tell me, see 4s orbital is transformed to A1G. तो इनके आपको दो लेवल मिलेंगे. See A1G, that is one is bonding, another is anti-bonding. Okay, you will get two different level. One is bonding, another one is anti-bonding. So see, this is a bonding level. Look at here, A1G, and this is a anti-bonding. Okay, A1G is a having list energy. Now next is you can have a, see 4p orbital, that is you can say px, py, and pz. So they are transformed into, see they are coming to T1U. Okay, this is T1U level, and 3d orbital is split into EG and T2G. So it's a EG level. See, this is a EG level. Okay, just look at the diagram. We resume shortly. So here you can have a C, A1G, T1U, and EG. Now these three are, because T2G can't form sigma bond. So see, T2G remains non-bonding. Look at here. And EG is a bonding. So these are the bonding orbital, A1G, T1U, and EG. Now A1G, its anti-bonding orbital is A1 star G. EG anti-bonding is EG star. एंड T1U है, उनकी एंटीबॉन्डिंग है वो T1U स्टार है. अभी ऑर्डर देखो नीचे, सबसे कम एनर्जी A1G की है, तो इसका मीनिंग ये नहीं कि एंटीबॉन्डिंग की सबसे ज्यादा होगी, वो बिलो दी T1U स्टार है, वो याद रखना है. सो सी दिस इज द वे appropriate combination is take place. Now in octahedral complex you are having say 6 ligand. It's a Ml6 complex, so you can have a 12 electrons. Okay, 12 electrons of ligands are there. So they occupied in which orbital, which ligand group orbital? So you can say it is in, yes, it is in, yes, it is in sigma A1G, that is ligand group orbital, then sigma T1U, okay, sigma T1U, and then sigma EG. It is occupied in this orbital. See, these are the three orbitals. EG is a 2 and A1G is a 1. So total 6 orbitals are there. So you can have a appropriate symmetry adapted linear combination. So these are the 12 electrons. So now these 12 electrons, now once this orbital is combined, so you are getting, see this is a combination. A1G is combined with sigma 1 orbital of ligand. T1U is combined with T1U sigma of ligand, and EG is combined with EG. So these are the combinations. See, this is a combination. EG is combined with EG orbital. Here you can have a T2G and EG. So EG orbital gets combined with this EG. T1U combined with T1U. So in this way, so there are say 12 electron arranged, 2 in A1G, 6 in T1U, 4 in EG. So in this way you can have a 12 electron of ligands. Now see, earlier what happens? There is a energy difference. energy difference between Eg and T2G in a normal case it is a octahedral, but now once it is involved in the sigma bonding, then energy difference between T2G orbital, that is bonding, and anti-bonding Eg star is a octahedral. And see, this is cannot be explained by, you can have a, see, you have only explained this energy difference between these two is 10 dq, and that is from crystal field splitting theory. Okay, but difference between T2G and Eg star is also here 10 dq, so that is explained by molecular orbital theory. See, look at here, this difference is octahedral splitting, or you can say 10 dq. So this is a, see, upper three are anti-bonding, lower three are bonding, and T2G is a non-bonding because T2G cannot form sigma bond. So in this way, see, these are the 12 different orbitals. Sorry, these are the various orbitals in a sigma donor complex or in a sigma complex. So is it okay?
Yes, sir.
Fine. Now see, so here, what is the first step? Is see, from the symmetry properties of metal and ligand, you can have a A1G orbital. You can have a A1G orbital which overlap with two gives two molecular orbital, that is A1G and A1G star, that is represented here. Okay, A1G gives A1G and A1G star. Second step is triply degenerate metal and ligand orbital, that is T1U set. They gets overlap to gives again two orbitals. One is bonding, another is anti-bonding. Look at here. This is a, you can have a bonding, and this is you can have anti-bonding. And doubly degenerate Eg orbitals of metals and ligands, they get overlap to gives two Eg orbitals, two set. One is Eg bonding, another one is Eg anti-bonding. And T2G remains non-bonding. And therefore it has same energy as to metal. You just compare the green line. Now energy difference between T2G and Eg star molecular orbital is octahedral splitting, or you can say 10 dq. So here it is 10 dq. And a given molecular orbital has character associated with atomic orbital nearest to an energies, and therefore 6 bonding molecular orbitals will have a primarily the character of ligand orbital, while the anti-bonding molecular orbital will have a mainly character of corresponding metallic orbital. So if you go for if you just compare this properties of this 12 orbitals, so these 6 orbitals, see, this 6 having character similar to ligand character. A1G, T1U, Eg का जो character है वो ligand की ओर रहेगा, और anti-bonding है, that is where, so its character is towards metal. This is towards metal character, and this is towards ligand side. Character is therefore the 6 bonding molecular orbital will have a primary, or you can say preliminary, the primarily character of ligand orbitals, while other 6 anti-bonding having mainly the character of corresponding metal orbital. So this is a MO diagram for sigma bonding. What happens in pi bonding? So ligand which have orbitals with pi symmetry with respect to octahedral axis are capable of pi bonding interaction with metal atom. ligand के पास pi bonding के लिए सिर्फ pi ऑर्बिटल के लिए पाई सिमेट्री होना चाहिए, तभी वो मेटल के साथ इंटरेक्शन करेगा और पाई बॉन्ड फॉर्म होगा. So metal and ligand orbital involved in pi bonding are perpendicular to ML axis. So this is, you can have a Z axis. So this is a X axis and Y axis is on your side. So these two are in a perpendicular. So X and Y component is responsible for pi bonding, and Z component is responsible for sigma bonding. If we take ligand L1 here, this is L1. So Px is along the axis, and that's why this is formed. This is a Px which is along the x-axis, and therefore it is from sigma bond. But Py and Pz are perpendicular to Py and Pz orbitals are perpendicular to x, or you can say x-axis. So these two form which bond?
Pi.
Pi bond. Okay, so perpendicular orbitals can only form pi bond, and another one is they are form sigma bond. Here along x-axis you can have a sigma bond, and perpendicular, that is Py and Pz, can form pi bond. Now along axis sigma bond and perpendicular it is pi bond, and for pi bonding d orbital of metal which is used, which is having T2G symmetry. So T2G is a non-bonding, that is dxy, dyz and dxz. So that is responsible for pi bonding. So three symmetry adapted pi symmetry ligands, that is T2G. T2G है उनकी symmetry, it is very good match with pi bonding. So now we go for that. So there are, see, this is from sigma bond. So this T2G orbital of ligand group, these are the ligand group orbital various. So T2G orbitals of ligand group can form pi bond with T2G orbitals of matter. They are only from the pi bond. ये basically dxy, dyz and dxz में से आएगी. ये T1U है वो px 4p orbital है ना, उसमें से. ये this is from a sigma bond. ये भी है, तो इसी तरह से. So this will form the particular pi bond. So T1G and T2U. Here see T1G, T2U. Ligand orbitals are non-bonding because there are no metal orbitals of such symmetry. तो ये दोनों है आपके पास T1G and T2U. So they are remains as non-bonding. Okay. They cannot form the bond. So you can just match the symmetry with both. कौन कौन सी सिमेट्री मैच हो रही है? चलो सब सिमेट्री दे दिया मैंने, लिगेंड्स हो रहे हैं दोनों के लिए. यू कैन कंपेयर. ऊपर है यहाँ पे T1G है, नीचे है T1G
नहीं, T1
नहीं है. ओके ओके ओके. T2U भी नहीं है. ओके, अभी दो चीज मैच हो रही है, T1U and T2G. So T1U having symmetry similar to metal, having symmetry similar to ligand. See, these two having same symmetry. So which bond they are form?
pi bond.
Pi bond cannot form by T1U. We have already told. Only pi bond is formed by T2G. तो ये कौन सा bond form करेगा? They are involved in sigma bonding, not in pi bonding. Okay, but T2G, these two T2G orbital can involve in pi bonding. तो सी इसमें दो तरह की सिमेट्री मैच होती है, दैट इज T1U and T2G. So T2G can form pi bond, T1U cannot form pi bond, it forms sigma bond. So now there are two different cases. One is ligand T2G orbitals are filled. ligand जो है उनकी orbitals है ligand, ये filled है सपोज, तो क्या होगा उस केस में? कौन इलेक्ट्रॉन किसको देंगे? ligand की जो T2G है वो filled होगी, एंड सो फील्ड है, सो देर आर ऑफ इलेक्ट्रॉन्स है, तो रिपल्शन ज्यादा, इसका इनकी एनर्जी हो डिक्रीज होगी. दे आर हैविंग लोअर एनर्जी देन पार्शली फील्ड मेटल ऑर्बिटल. मेटल की जो ऑर्बिटल है वो उसमें कम इलेक्ट्रॉन है, पार्टली है फील्ड. तो उस केस में क्या होगा? पार्शियल फीलिंग है तो कम इलेक्ट्रॉन है, सो इट इज बिहेव एज इलेक्ट्रॉन डेफिशिएंट. तो कौन किसको इलेक्ट्रॉन देगा?
ligand to metal.
यस, सो वन इज लिगेंड टू मेटल, तो इसको बोलते हैं पाई डोनर केस. दिस इज द पॉसिबल विथ पाई डोनर लिगेंड. ये कब पॉसिबल होगा?
Metal in high oxidation state.
when ligand is pi donor. Okay, metal is of course all this criteria is there, whatever is there for charge transport spectra, but here ligand is a electron donor, so this is possible by मेटल टू लिगेंड. सो पाई डोनर, दिस इज ए केस ऑफ पाई डोनर, और इनकी जो एनर्जी है वो कम रहेगी लिगेंड ऑर्बिटल केस कंपेयर टू मेटल. दूसरा केस कौन सा है? केस नंबर 2,
मेटल टू
लिगेंड की जो ऑर्बिटल है T2G
Metal.
ऑर्बिटल्स ऑफ लिगेंड्स इज एम्प्टी एंड मेटल हैविंग पार्टली फिल्ड. मेटल की जो ऑर्बिटल है T2G मेटल वो पार्टली फिल है, एंड लिगेंड की जो ऑर्बिटल है इट इज एम्प्टी. तो उस केस में क्या होगा? मेटल इनको इलेक्ट्रॉन देंगे. ओके, तो यहाँ पे लिगेंड की जो एनर्जी है वो हायर रहेगी. ligand orbital lies in higher energy level, here ligand orbital lies in a lower energy level. So what happens in both the cases? Look at here, ये मेटल की एनर्जी लाइन है और ये लिगेंड की है. सो कंपेयर टू मेटल, लिगेंड की एनर्जी कैसी है? लिगेंड ऑर्बिटल की एनर्जी लो है. ओके, इज इट ओके?
Yes, sir.
So in first case, pi donor, it is a case of pi donor. So what happens in this case? You can have a, see, when metal having only T2G orbitals, at that time, see, there is a the energy difference in a sigma bonding. When metal form the sigma bond, at that time, energy difference between T2G and sigma star. See, this is a partly field. Look at here, 2 electron is there. So energy difference between sigma star and T2G is a delta octahedral. That is called 10 dq. यहाँ पे भी हमने देखा था, यहाँ पे सेम एनर्जी डिफरेंस है. सी, यहाँ जो देखा है वो. But whenever you are having see such case, that is, it is ligand is a pi donor, so at that time you are getting 2 orbital from this T2G set, T2G bonding and T2G anti bonding. This is a T2G anti bonding and T2G bonding, and Eg star remains as it is, having same energy. See, इनकी एनर्जी में कोई चेंज नहीं हो रहा, इनकी एनर्जी है वो. तो उस केस में क्या होगा? You will get again T2G star, that is called anti bonding. यहाँ T2G और Eg के बीच में डिफरेंस 10 dq था. Now difference between T2G star and Eg star is 10 dq. This difference is 10 dq, and that's why, so see, this is the case of, so it is we call pi donor, क्योंकि लिगेंड लाइन है उनकी एनर्जी कम है, तो ये डिफरेंस यहाँ पाई मेंटेन रहेगा. दिस इज वन केस नंबर 1. केस नंबर 2 में क्या होगा आप इससे प्रेडिक्ट कर सकते हो? लिगेंड ऑर्बिटल है, उसका डायग्राम कैसे रहेगा? केस नंबर 2 में लिगेंड की एनर्जी है वो ज्यादा रहेगी, किससे?
metal.
मेटल से. तो अगेन सी यहाँ पे Eg स्टार एंड T2G स्टार, ये देखो T2G स्टार और Eg स्टार के बीच का डिफरेंस है वो 10 dq था. नाउ हियर व्हाट हैपेंस, सी दिस ऑर्बिटल इज स्प्लिटेड इनटू इन दिस वे. T2G स्टार है, उनकी एनर्जी इससे Eg स्टार से बढ़ जाएगी. यहाँ क्या है? Eg स्टार से कम है. देखो T2G स्टार है, उनकी एनर्जी है इट इज लेस देन Eg स्टार, बट यहाँ पे इट इज ग्रेटर देन Eg स्टार, और Eg स्टार तो अपनी जगह पे रहेगी. तो किसके बीच का डिफरेंस 10 dq होगा?
T2G and Eg star.
T2G and Eg star. Okay, so this is the case of pi acceptor ligand. Okay, this is the case of pi acceptor ligands like carbonyl ligand, especially pi bonded ligands.
Pi acidic ligands.
So this is called pi acidic also, you can say. Yes, it is having highest acidity. So pi, ऐसे कौन कौन से ligands है जो इसे कैरेक्टर पोजेस करता है? So
Carbon
Ca,
monoxide, nitrogen monoxide.
yes, NO plus, Cn minus, CO. Okay, so these are the which having or sigma as well as pi symmetry. इसमें दोनों तरह की सिमेट्री है. तो इसमें स्पेशली NO प्लस, Cn माइनस and CO. These are the ligands which have a vacant pi star orbital. Pi star orbital is vacant. So they are receive the electron from metal T2G, and such ligands will give you metal to ligand pi bonding, or you can say back bonding. यहाँ पे metal to ligand pi bonding बनेगा ऐसे, or you can say back bonding. Okay, they receive the electron from metal. फर्स्ट केस में क्या है, Cl माइनस है और Br माइनस है, वो क्या करेंगे,
ligand to metal.
यस, सो वो भी ऐसे ही करेंगे, ये दोनों चीज इसमें आ जाएगी, यहाँ से लिगेंड लाइक Cl माइनस Br माइनस, इसमें भी आप NO प्लस Cn माइनस CO लिख सकते हो, पोजेसिस both the symmetry sigma as well as pi. So halide ion से स्पेशली इसी halide ion के लिए लिखेंगे, halide ion act as a sigma donor and pi donor both. Halide is a sigma and pi donor. So it shows which transition,
Ligand to metal.
ligand to metal. So now this is the case where you can have a 10 dq value. In the case 2, it is 10 dq is a difference between T2G and Eg star, that is called antibonding. Now what happens is, this is the one of the diagram, MO diagram. आपके पास 3D orbitals है. This is a complex which you can say copper complex. It is a copper complex. So x is equal to 3. So you can have a 4s1 3d9 sheet, it's a 4s0 3d9 9. Copper is having electronic configuration is 4s2 3d9. तो कौन सी सिस्टम आएगी, D8, क्योंकि कॉपर में इलेक्ट्रॉनिक कॉन्फ़िगरेशन कौन सा है, कॉपर में
D8.
D8 है. So you can have a see here, look at here, this is a D8 because copper is in a +3 state. So see, these are the 8 electrons of copper. Here these are the 8 electrons of copper, or you can say. On the other side you can have a different electrons. This is called case of pi donor. So pi donor में से दोनों चीज आएगी, कौन कौन सी दोनों चीज, पाई डोनर है तो पाई डोनर के केस में आप देखो केस नंबर 1, इसमें दोनों चीज आएगी. पाई डोनर इज नॉट ओनली पाई डोनर बट इट इज ऑल्सो सिग्मा
Sigma donor.
donor, yeah, sigma donor भी है और पाई डोनर भी है. So better way you can see understand this diagram, so you can be having this picture is clear. So whenever sigma bonding is there, sigma only, तो उस केस में से आपको यही सिग्मा ऑर्बिटल से कंसीडर करना है, दैट इज A1G EG एंड T1U. इसमें 6 लिगेंड हो गए बिकॉज ये 6 ऑर्बिटल्स है तो उनके 12 इलेक्ट्रॉन आ जाएंगे. हियर यू कैन हैव 12 इलेक्ट्रॉन्स. सो यहाँ पे सी 12 इलेक्ट्रॉन से, दिस इज द स्प्लिटिंग डायग्राम. यहाँ पे कंपैरेटिव इनकी एनर्जी लो है, देखो लो लाइटिंग एनर्जी रहेगी कैसे, इसकी कंपैरिजन में एनर्जी लो है यहाँ पे. सो A1G है, उसके बाद T1U, देन नेक्स्ट कॉम्बिनेशन इज EG, उसके बाद T2G है वो नॉन बॉन्डिंग है, देन यू कैन हैव EG स्टार, then A1G star and T1U star. So this is the diagram where 12 electron accommodate. This is 2 here, 6 in T1U, 4 in EG. In this 12 electron of ligands are comes. Now these are the 6 electrons from metal. These are remains as non-bonding. You can have a suppose 6 electrons with metal. So total is 6 ligand orbitals which are there. So They are having 12 electron in a bonding and 6 in a non-anti-bonding. So here energy difference between which two level is 10 dq?
T2G and EG star.
Yes, this is a 10 dq. Now, if you go for pi donor ligand, pi bonding, metal to ligand, pi interaction. So see, this is the case for sigma. Red indicates it is, but of course it is a case of sigma. And pi orbital, which is having energy here, see, you can look at here. T1, you can have a see energy of EG star. You can compare with this one. See, this is a case of here ligand having, of course, low energy. So EG star and T2G difference is a 10 dq. But when very important things over here is this is responsible for pi orbitals, pi bonding. ये सारी हमने लिखी थी पाई बॉन्डिंग में. इसमें से कितने की सिमेट्री मैच होती है इनके साथ? आपने यहाँ पे देखा था सी
T2G.
T2G मैच होती है पाई बॉन्डिंग के लिए, ओके, एंड T1U फॉर सिग्मा बॉन्डिंग. तो यहाँ क्या होगा, सी T1U है वो इट इज फॉर सिग्मा बॉन्डिंग. सो T2G है उसमें से आपको दो मिल जाएगी, T2G स्टार, T2G एंड T2G स्टार. सो दिस इज फॉर
Rest will be non-bonding.
yes, rest remains non-bonding. So T2G symmetry is match with this one. So you can have a remaining that is called T1G, T2U and T1U. So these are the remains as a non-bonding. Now this is comes here and its anti-bonding is this one. So this is from pi bond. So of course you can have a 12 ligand pi star orbital. These are the 12, 3 plus 3 plus 3 plus 3. Out of that, say 6 electron gets accommodated here. So now this is in a pi orbital. इलेक्ट्रॉन तो दोनों में सेम ही है, बट यहाँ पे सी पाई ऑर्बिटल है. सो नाउ फर्स्ट केस में वो जो T2G नॉन बॉन्डिंग थी, नाउ इट इज अ बॉन्डिंग, पाई बॉन्डिंग हो गई, ओके. और ये पाई डोनर इसलिए है सी लिगेंड हैविंग पार्शियल इलेक्ट्रॉन एंड दिस इज हैविंग सी ऑलरेडी इलेक्ट्रॉन. ये जो है ना इनके पास 6 इलेक्ट्रॉन है T2G. सो इट इज ए डोनर. सो इट इज कॉल्ड केस ऑफ पाई डोनर. इज इट क्लियर?
Yes, sir.
Okay. Now same way, so you can see come to here. So this is from pi bond. See, this is a T2G. T2G set of ligand can only form the pi bond. This is from pi bond. That is, it will give you T2G and T2G star. This is the case of pi bonding. Okay.
Yes, sir.
And now this is formed. This is responsible for which bonding?
Sigma bonding.
Yes, it is for sigma bonding. See, this is from sigma bonding. Okay, so here in this way you can just accommodate electron of total electrons of metal and total electrons of ligands. You can accommodate in appropriate way. So you can have a the diagram in which, see, this is the case of pi donor ligand. Ligand is a pi donor. That means here 6 electron is donated by ligand to metal orbital. Metal having partly filled orbital and ligand having fully filled orbital. So metal can donate its electron to ligand orbital. So in short, see, if you go for its character, donor character, so or you can go into spectrochemical series. So pi acceptor ligand comes first. That is CO, CN, PR, okay, all this. Then next is sigma only donor ligands. Then weak pi donor ligands. And then both sigma and pi donor. It is a pi donor, of course. Cl minus, Br minus, F minus are the pi donor. So what happens? See, in a higher oxidation state, which transition is take place?
LMCT.
Ligand to metal, yes, because metal is electron deficient, its oxidation state is high, and therefore it is electron deficient. So ligand is electron rich, oxygen, or here also oxygen. So it will give ligand to metal charge transfer spectra. And if ligand is a pi acceptor, especially this type, so you can have a
MLCT.
yes, MLCT type transitions. So metal can donate electrons. So depending on nature of non-bonding ligand orbitals and oxidation state, you can have a here see oxygen having lone pair of electron, non-bonding orbital. So it donate the electron. So depending on non-bonding ligand orbital and oxidation state of metal, you can have a various transitions. It may be from metal to ligand, or it may be from ligand to metal charge transfer spectra. Now look at here. So this is the case of ligand to metal. That means ligand की orbital है वो filled होगी, metal की है वो partly filled होगी. तो उस केस में जैसे हमने शुरू में बताया ऐसे दिस इज ए T2G एंड दिस इज ए T2G स्टार. तो उसमें कौन किसको इलेक्ट्रॉन देगा? ये लिगेंड है,
नॉन बॉन्डिंग टू T2 स्टार.
ये लिगेंड की ऑर्बिटल है. सो लिगेंड डोनेट इट्स इलेक्ट्रॉन टू मेटल. ओके. Filled non-bonding ligand orbitals that can donate electron to empty metal orbital. And second case ऐसे है सी जिसमें अब देख सकते हो यहाँ T2G filled है, दिस इज एम्प्टी. तो इसमें इलेक्ट्रॉन एंटी बॉन्डिंग में रिसीव कर होते हैं यहाँ पे. But see T2G having 6 electron and ligand having empty orbital. Empty orbital ligand के पास ये सारी है, T1U है, T2G है, सब सपोज एम्प्टी है, इसमें इलेक्ट्रॉन नहीं है. तो उस केस में metal can donate electron to ligand, so you can have this type of charge transfer spectra. So here this energy gap is small and it can donate electron to this one. So T2G is here electron donor. यहाँ पे जो है वो ligand के orbital है, that is electron donor. T2G is electron acceptor, T2G star. Antibonding is the electron acceptor and T2G is the electron donor. So that is we call charge transfer spectra. Okay, is it clear?
Yes, sir.
Okay, so here see we have, I think, covered most of the concept of this MOT, molecular orbital theory. And again see ligand field theory, it is very close to MOT. Nothing new. See ligand group जो theory है, it is ligand field theory it is a mixing of both. Rather you can say it is more close to crystal field splitting, and it is a combination of both the theory. That is you can have a ligand field theory. What is ligand field theory? That we will also see what happens exactly in the ligand field theory. Of course it is like to CFT. Okay, उसमें हमने जो 10 TQ वाला कैलकुलेशन किया था ना,
Yes,
वो
sir.
सारी है ना, उसको ligand field बोलते हैं. So ligand field theory is basically it is similar to it is most nearly a ligand field theory which is very close, or it is developed from the amalgamation of crystal field and MOT by combination of this both the theory. That is called amalgamation of crystal field and you can have a molecular orbital theory. So that will give you ligand field theory. So ligand field theory take into account of the external, it is especially for metal ligand interaction by a parameter of 10 dq. 10 dq के हिसाब से वो उसको metal ligand का interaction है वो decide करते हैं. That is we call so ultimately calculation of 10 dq value. ligand field theory. It is basically on which parameter it is there. So it is, this theory is nothing but the amalgamation of both CFT and MOT. And this theory is based on the, it is based on metal ligand interaction, metal ligand interaction by the parameter called ten DQ. Okay, 10 DQ value. So you can see have a parameter 10 DQ can be theoretically evaluated by taking all metal ligand interaction into consideration. So that means splitting of metal ion term, and on the basis of that splitting, atomic orbitals, or you can have a whole atomic configuration by ligand. So it is ultimately that will give you idea about, you can say it is very sophisticated way you can explain it by whatever things we have explained in CFT, we can in a sophisticated way you can explain it in ligand field theory. So ultimately it is an interaction between metal and ligands on the basis of calculation of 10 DQ, and the most useful theoretical treatment for interpretation of especially visible spectra of Gillette complex proposed by तनाबे एंड सुगेनो. वो डायग्राम भी उसमें हम देखेंगे जो अनदर सेपरेट चैप्टर है. राका पैरामीटर से इवोल्यूट करेंगे जब स्प्लिटिंग होगा तो. ओके, बीटा जो नेफ्रोजेटिक सीरीज है तो वो सारे जो फैक्टर है ना, इट इज ए पार्ट ऑफ लिगेंड फील्ड थियरी. तो उसमें ज़्यादातर स्टडी करेंगे जो हमारा सेकंड चैप्टर पैरेलल चल रहा है उसमें. ओके, चार्ज ट्रांसफर. यस,
क्वेश्चंस को शेयर को देंगे. क्वेश्चंस यूनिवर्सिटी का जैसा क्वेश्चन आएगा यूनिवर्सिटी एग्जाम में,
पैटर्न पहले काम करते हैं. मैं आज जासर से बात करके और इस कितने मार्क्स का पेपर है, किस पैटर्न से जाना है, तो उस हिसाब से आपको पेपर पैटर्न्स और सारे जो क्वेश्चंस है ना, इनके जो क्वेश्चन बैंक वो मैं शेयर कर दूंगा. असाइनमेंट के जो पे आप वो भी लिख सकते हो एज असाइनमेंट. ओके, सो नो प्रॉब्लम. बट सी basically whatever PPT I have shared with you, so you can follow that material, so that is enough. And if you having reference book, if you want to read further, then you can read. Otherwise this material is enough. Okay, तो मैं डेफिनेटली जो आपको है ना पैटर्न, और कल जो पूरा दिन है वैसे फ्री है तो मैं उसमें पैटर्न कैसे पेपर आएगा और क्वेश्चन बैंक जो है 3 यूनिट स्पेशली उनके लिए भेज दूंगा आपको. सो नाउ सी इनिशियली हमने सिलेबस देखा है, उसमें देखते हैं कौन कौन से टॉपिक है. अभी कोई टॉपिक स्पेशल लेफ्ट तो नहीं है ना. अदरवाइज सी दिस चैप्टर्स आई थिंक मोस्ट ऑफ द पार्ट वी हैव कवर्ड. Here she look at the syllabus. So crystal field splitting diagram we have taken well for all these 3 complex. Both the series we have also written. You have to just remember the positions of ligand in particular series. Applications of CFT in especially site selection, yes, spinal and spinal structure. So ये टॉपिक है वो लेफ्ट है, तो इसको नेक्स्ट जो साइट सिलेक्शन स्पाइनल स्ट्रक्चर वाला देखेंगे. एंड एक्सपेरिमेंटल एविडेंस फॉर मेटल लिगेंड ओवरलैपिंग, सो वो तो सारे देख लिया. आज जो मोटिव देखा उसमें जो कॉम्बिनेशंस होता है वो सब. लिगेंड फील्ड थियरी, मोलिकुलर थियरी अप्लाइड टू मेटल कॉम्प्लेक्स. ओके, सो एक टॉपिक जो है कैसे स्पाइनल स्ट्रक्चर है या तो एंटी स्पाइनल स्ट्रक्चर है वो कैसे डिसाइड करेंगे. ओके, तो ये टॉपिक खत्म करके जो हमारा कंटिन्यू जो चैप्टर है उस चैप्टर में मूव करेंगे. ओके, नेक्स्ट लेक्चर में स्पाइनल एंड ये दोनों कंबाइन ले लेंगे. स्पाइनल एंड यूनिवर्स स्पाइनल स्ट्रक्चर एंड लोबाल पेयर कंसेप्ट है, आइसोलोबाल पेयर. सो वो दोनों है
आइसोबेल
या आइसोलोबल पेयर जो है वो दोनों है ना, वो कंबाइन एक लेक्चर में लेके उनके रिलेटेड क्वेश्चंस देखेंगे। एंड देन वी मूव टू दी मेटल ट्रांजिशन वाला जो चैप्टर है, ऑर्बिटल डायग्राम एंड टीएस डायग्राम, वो सब नेक्स्ट लेक्चर में देखेंगे।
Yes.
ओके, सो थैंक यू वेरी मच।
काल टाइम टेबल काल को